So next on my list, we know what this is, what it represents. It's a definite integral. I use an adjective definite because I've got bounds of integration. But what this represents is, well, maybe a lot of things, but for you and I so far, it represents a one finite fixed real number, which could be interpreted as the area underneath that curve as x ranged from here to here. This, however, is what I sometimes refer to as an indefinite integral. And what it represents is a collection of antiderivatives for the function lowercase f in the integrand's position, at least over some interval I. So this represents a single finite fixed real number, if it exists. This represents an infinite collection of functions, in particular, the collection of all antiderivatives of lowercase f. Now, as far as antiderivatives in general are concerned, or indefinite integrals, I should say, page 403 has a huge list. Here's one of them. That's kind of powerful anti-differentiation. Here's another one. You can prove it just by differentiating that going backwards. You get what's in the integrand's position. Here's another one. Bottom line is I remove these two symbols simultaneously, and I generate a single antiderivative for this beast in the integrand's position and tack on my constant of integration. Now, I'm afraid there are a couple not on page 403 with which I need you to be familiar. May not be ground shattering this semester, but it will be in the near future. So add to that list this indefinite integral. As well as this one. And let me bore you to death with a very quick and easy justification. If I had more expertise with the integral calculus, I could actually generate these from scratch just by making something I call a trigonometric substitution, but we don't have those yet. So let me crank it up by maybe by doing the opposite. Because this is supposed to be the collection of antiderivatives for this beast. I can prove this equality holds as long as when I differentiate this, I get what's in the integrand's position. So allow me to do just that. Let me differentiate respect to x. This business. I think it gives me this. Chain link. However, that gives me this. And that gives me this. So I think I've just proven this is true because I went backwards. I differentiated this and got what's in the integrand's position. Just as easily, let me verify the second one. Constant gets carried along. Differentiate inverse tangent of anything. Chain rule. Well, here too, I just proved what I wanted to show.